calculator's out and open and ready to go in radian mode. However, one more time. If you ever get a radian, an angle measure, right? A radian, an angle measure in radians, and you need to think about its position, would it be more helpful to get it in degrees? And hopefully the resounding answer is yes. So please don't hear me that you should never go to degrees, you should never think in degrees. I'm just saying you should never answer in degrees. Are we good with that? Okay. So then yesterday we were talking about the beginning of vectors with magnitudes and directions. We talked about how a vector has an initial point, has a terminal point, an ending where the arrow is. The arrow does not mean going on forever. The arrow just means the direction of the movement, the motion, the force, the tension, whatever it is that this vector is trying to show. Every vector can be broken into horizontal and vertical components. And we'll talk a little bit more about this in just a little bit. But what we were just saying yesterday was, hey, remember magnitude and direction, either from Despicable Me or from pre-cal or maybe from both. Every vector has both magnitude, has some sort of quantity to it, a how muchness as far as how great is the force, how fast is the speed, etc., etc. But it could also have, or it does also have, a direction angle. So we solved yesterday just using a right triangle, Pythagorean, to find the magnitude, tangent inverse to find the direction. However, if you had plugged this in your calculator in degree mode, we'll go there, it's easier to think about it. If you had plugged this in degree mode, what would you have gotten from your calculator? Negative 60. Is negative 60 truly showing the position or the direction of this vector? No. It would be the complete opposite direction. So we have to use a little bit of our skills to say, oh, wait. Okay. The calculator gave me negative 60. That's right. Tangent inverse is restricted to negative 90 to 90, negative pi over 2 to pi over 2. So all we would have to do is add 180, which would end us at 120, which in radians would be 2 pi over 3. Okay. What if they gave us a direction like this, where it says find the component form of a vector with magnitude 3 and a direction angle of 40? Someone in physics talk me through how to get the component form. Noah.
So the magnitude of the block vector is 3. That is the diagonal.
Can I put length? Is that okay? Okay.
If you make a graph like and you go 40 degrees up from the x-axis and draw one and with the arrow, and that would be the vector, which is 3.
Okay, so 40 degrees is right there. The length of this from beginning to end would be the 3.
And component form just means that you're looking for x value, which is run comma with y, which is the rise.
Or as he said, the rise, the run.
Yeah, I think that was.
Yeah, the run and the rise. These side carets are pretty unique to vectors. I almost said vertices, that's weird. The side carets are pretty unique to vectors. You could think of it, though, as like an ordered pair with an x and a y, but it strictly denotes an x distance, a horizontal change, and then a vertical change. In pre-cal, sometimes we call it xy. Usually we call it ab. Sometimes we would do it in linear combinations where we would have a times I plus b times, j. There's linear combination form. But all of them kind of denote the same thing, breaking this, in a sense, diagonal vector, which doesn't have to be diagonal, but frequently is, into its horizontal and vertical components, breaking it down. So how would we, another physics person, how would we use magnitude and direction, the 3 and the 40 degrees, to get our horizontal and vertical? Sine and cosine. Sine and cosine. Sine and cosine. Because it's really just a right triangle, right?
Isn't this an endeavor card?
Polar to parametric.
Probably should be. Have we made a forever card about vectors? It's similar to polar, right? It's specific to polar. Polar is going to be separate. However, if you think about it, that's perfect because in polar, wouldn't we take or be given a hypotenuse and an angle, and we would need to find the horizontal and vertical components? So it's very similar. So as you guys were saying, we're going to take the magnitude, we're going to take the direction, we're going to say, hey, let's just use sine and cosine. So we can go ahead and say 3 cosine of 40 is going to be the horizontal. Cosine adjacent over hypotenuse, solve for adjacent. Cosine is adjacent over, did I say that weird? Cosine is adjacent over hypotenuse, solve for adjacent. Lo siento. What's your vertical component going to be?
3 sine cosine.
Yeah, 3 sine of 40. I trust that we can plug that in our calculators, okay?
Yes.
Is our book an AP edition? Is our book an AP edition? Yes. Why'd they give us degrees? They're trying to help us review the basic pre-cal stuff, intro to physics of vector. So they're using the basic notation that would be used in those books. However, once again, if it's on the calc, it's not going to be in degrees that I've seen. Was there a question I totally passed over?
My question was, it's in degrees. What do we
Oh,
do?
yeah. I haven't seen one. They could give you degrees. I'm not saying they couldn't. But you guys would just know to change your mode, right?
So when instead of saying direction angle of 40, would it say something like
Pi over 3, 5 pi over 6, yeah. And to be honest, I haven't seen this type of question be on the AP exam that's trying to like, hey, remember vectors? They're a thing. Okay, let's talk about the calculus. Does that kind of make sense? Okay, so let's zoom in on this. This is our forever from section 11.2. Our endeavor, I apologize. And there's a lot of stuff going on in here. I have highlighted the trickiest one, the one that students get. Yeah. The one that students get wrong the most. I've highlighted the one that students get wrong the most. Position vector. A position vector. There can be vectors that are denoting lots of different things. It can just be like showing a change in position, going from point A to point B. It could be a position vector. It could be a velocity vector. At the very beginning of this section, I put V for vector, but it could have also been V for velocity. And if velocity, its horizontal and vertical components would actually be the horizontal velocity and the vertical velocity. We were kind of dealing with that yesterday a little bit with x prime and y prime. But it would be as simple to find the velocity vector of just deriving the position vector, and similarly for the acceleration vector. Go ahead, Corey. T. Yeah, y prime of t. It looks a little bit like an absolute value or something, huh? Thanks for showing me that. The nice thing is the vector problems, if they show up, when they show up on a BC, are not usually very tricky, but you do have to recognize them when they come. Guys, does this vector calculus really apply to parametric? Yeah, because you have x of t's and y of t's, right? It applies to parametric, or parametric is maybe being applied to the vector calculus. It makes sense, two-dimensional motion. And vector calculus is only applied to motion. You could have vectors that are denoting all sorts of different things besides motion, but the nice thing is, as far as I have seen, BC vector problems only deal with motion. Something is moving, a particle is moving, a car is moving, someone's moving on a path in the XY plane. It's not dealing with work or forces or tensions or cables or anything like that, even though it could definitely be applied to that. But the nice thing is in BC, just motion. Why is speed, why did I highlight the fourth asterisk? Why is speed possibly a very tricky thing to think about? Yeah. You're just like, take the velocity and make it absolute value, but that is not it at all. Because speed is the magnitude of velocity, which, if it's a single numeric value, yeah, well, if velocity is negative 30 feet per second, speed would be 30 feet per second. So we think absolute value when talking about a single numeric value. However, the problem is if we're talking about an entire vector, to find magnitude, we are not just taking literally the absolute value of those two functions. We are instead finding the magnitude of the vector, which is always found by taking the horizontal component, the vertical component, and saying, hey, what's that diagonal result? Pythagorean theorem. So if we were to go back just really quickly to the very beginning vector, because now let's go ahead and apply it really quickly. Let's say this is not v as in vector. Let's say this is v as in velocity. Some of you might have been a little confused as to why I was showing x prime and y prime. Now it makes a little more sense. Let's say this isn't v as in vector. This is v as in velocity vector. So if I knew the horizontal velocity and if I knew or could find the vertical velocity, how am I going to find the speed? I wouldn't talk about these horizontal and vertical velocities separately. Instead, I would be talking about the overall magnitude, which by definition, in a sense, whenever you do a squared plus b squared and square root it, will be positive. But the concept is going to be a bit more complicated than just throwing in some absolute values. Do you guys see why I said Pythagorean theorem? If you got that guy and that guy, just go ahead and do a squared plus b squared is c squared. Dun, 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 dun. Magnitude. Now, real quick, notation. In your forever card, I'm coming right back. In your forever card, they show absolute value of velocity. You can think that, my pre-cal people. We've also seen magnitude denoted by a double absolute value. That might be a little bit more helpful as far as magnitude, and that should be okay. This shouldn't mess you up going to the traditional magnitude notation. Kyle, do you need me to go back? Okay. No, vector is the little arrow that's put on top.
Yeah, or it's super bold.
Or it's bold, but we don't really do it bold because handwritten, I don't like the bold. So I put the little arrow on top. There we go. Yeah. Vector. The little arrow is just denoting it as a vector. You're right, you can see bold letters, and the double lines are showing magnitude, which the absolute value, in a sense, is also showing as well. We use absolute value with complex numbers when talking about the magnitude of complex numbers. I think we just used I think the double lines are pretty common, though. Did you guys use that in physics for magnitude?
That was first semester. We did one chapter and guessed.
Okay, that's fun. All right, so then coming back. Guys, do you see any ways of remembering distance traveled? Integral of the speed. That hasn't changed, but what has changed? Whose speed is, right? Or how to find it. So, whole total distance traveled, still the integral of speed. That's always been that way. Displacement is the integral of velocity. Total distance traveled is the integral of speed. But now we have to go ahead and apply, that's right, speed is going to be magnitude, aka Pythagorean theorem. Displacement, that's a little different though, right? Or is it? What's displacement always been? Integral of velocity. No, are you distracting people? And the integral of velocity, aren't we going to take, who's the velocity vector? Oh, so it's not really that different. Displacement is still the integral of velocity, but the integral of velocity is put into its component form, and so therefore we could just take the integral as far as the horizontal change and then the vertical change. Does that make sense? Okay. And then last but not least, what's this? The magnitude of acceleration.
Is that considered a vector?
Yes. Thanks, I didn't throw my vector arrows in. The magnitude of acceleration would be as follows. Does that make sense? That it would be velocities, not velocities, I apologize, the horizontal and vertical components of acceleration, but Pythagorean theorem?
Yes.
Hopefully the answer is yes. Okay, let's play. I apologize. Velocity is a vector. Speed is not a vector. So the magnitude is more of a quantity, and yet if you have functions, it might not actually be a single number, but it would be like an expression. Okay. Kiddos, there is one thing that I kind of talked about the other day at rest, and I still think it's important. What did we talk about when I was talking about being at rest? Both horizontal and vertical. So let's go ahead and add that at the very end of our endeavor card, okay? At rest, it's a problem-solving clue. It's not specifically a formula, and yet I think problem-solving clues can be helpful, like way back when, CalcAB. When we talked about initially time was equal to 0. When we talked about when something hits the ground, what's 0? Nope. Position is 0. Okay. So some of those hints, like that one that we might initially get wrong, we need to keep an eye on or keep an eye out for. Keep a lookout for. Anyway, at rest is going to be one of those with vector calculus. So I would add at the very bottom of our endeavor card, at rest when a particle's speed is 0 in both directions. AKA, we would put when the horizontal component and vertical components of the velocity are equal to 0. Because if just the vertical one is equal to 0, but there's a horizontal, is that thing stopped? No, it's moving horizontally, right? If the horizontal, Yuki, shush. If the horizontal one is 0, but the vertical one is a value, is it stopped? No, it's rising or falling. So we need both of them to be stopped. That one is endeavor number? Is that it? 31? Okay. Okay. I'm going to put a little add. At rest. All right, cool kids. So what do we do for the first one? Yeah, so who's x prime? Y prime of t is equal to? I think this is the same one as the other day, huh? So therefore, it's going to be all 4 times, right, guys? Because I need both to be 0. So t equals 2. Doesn't tell me what units, but if it did tell me, I would put the seconds or the minutes or the hours. Okay. How about example 8? You guys see something new? Because the acceleration vector would just equal, right? Such that? So therefore, A of 3. What does that mean?
Acceleration at times, actually from 6 to 5 is the magnitude of space.
Right? Right? Okay. Why are you saying that speed is increasing?
Because they have velocity and acceleration.
There you go. Be careful. It's not just that acceleration is positive. You have to check both the acceleration sign and the velocity sign. So we would have also exactly had to think about v of 3 equals, I didn't even know, but I'm just assuming she's right. I would have to plug into velocity. I would have to plug into velocity vector and see that velocity is positive. And then plug into acceleration. Since they're both positive, then yes, I can say that speed is increasing. What if they were to ask me for the magnitude of the acceleration? Or what is the acceleration? Not acceleration vector, but what is the acceleration? Yeah, 61. Okay. So different things they can ask us. Long story short, I want to get you guys into the book work before we go much further. But let's go ahead and play with example number 9 to end today's class. I think after this we're like, meh. Yeah. If you are writing down the information on example number 9, yes.
Was the board still demon possessed after we left practice?
I think I oriented it again a little bit before lunch because I just couldn't handle it anymore. And after that, it was okay.
Someone get the soul.
It was